drawing comparison, and then
Sorry, Izzy. I'm sorry. It took a while to start recording. Can you start from the beginning?
Yeah. Sorry. This is the incredible tale of Arc Rock number 10, humbly presented by myself. The overview, I'm going to go through my hand sample observations, then my thin section observations, show my drawing comparison, and then go through the origins, because since it was an arc rock, I did have that little sheet of information that I was able to get some stuff off of. A shocking discovery that helped me a lot with the interpretation, and then the formation of my rock, followed by my references and my secondary rock that I looked at. So starting with the hand sample, it is a porphyritic biotite granite. As you can see, there's kind of a coarse texture. You can see the sort of, if you can see my cursor, the pink feldspar phenocryst sticking through up there. The mineral is most easily identified in the hand sample just by looking at it. There's a lot of quartz. The hornblende and the biotite kind of are harder to see, but they're both like there together, and obviously the feldspar. So then looking at the thin section, and I do have larger pictures of this as well, you can see the biotite has pleochroic halos around some accessory minerals, which I'm going to show in a second as well. There's also some zoned plagioclase over here and up this way. Those are the phenocrysts that you can see in the larger hand sample. So you can see that they're a lot larger than the other grains. Yeah, so there's biotite, there's some hornblende, some quartz. You can see it up in there. Orthoclase and plagioclase. I am going to show smaller pictures of some of the accessory minerals like the zircon and the chlorite. I do not have a picture of the apatite. Forgot to take a picture of that. And the magnetite you can see are these little black specks kind of just scattered throughout. This is a larger section. You can kind of see the pleochroic halos a bit better. I forgot to take a picture more zoomed in, but you can see it around in the biotite. And yeah, there's a zircon right there that I'm going to show a larger picture of that you can see in a second. These are my drawings. I tried my best. I also took these pictures with flash, I realized, and that kind of messed up the colors a little bit. It was kind of hard to do without the upper polar because there's just a lot of like blank space with just kind of like little mottled texture sort of thing. So I tried my best. I think my upper polar in does look a lot better, but also the flash kind of messed up the little details that I put in that feldspar, but that's fine, it's cool, it's whatever. So I didn't get a good picture of I couldn't find chlorite in the image that I showed, but I did find it other places in the thin section, so I did want to take a picture of it just to show that it was there. And this is a close-up of the zircon thin section, little piece right there that was in the picture that I showed. So what I know right now is that granite crystallizes through slow cooling, so pegmatites are a result of rapid cooling of remaining melt. So something must have happened along the way to make those feldspar phenocryst. It's relatively oxidized because it has accessory magnetite, and according to the little information sheet, is post-Archean. Probably, it said about Q9. I don't know if I'm saying that right. So that puts it about 1.1 billion years old. But what I need to know still, I wanted to find out, okay, no, never mind. What category my biotite granite fits into compositionally, which I had to look in the chapter in the textbook a lot for, the specific tectonic environment and what caused the sudden uplift in formation of the feldspar pegmatites. So looking at the origins of it, I did find this geologic map of Precambrian bedrock of Minnesota. My rock is from Rockville, Minnesota. Crazy. It was noted to be probably QAnon, and when I looked into this sort of area of Minnesota, there's a lot of quarries and mines there. There's a lot of different types of granite in that area. But mine, as you can see, is called a Rockville. Oh, that pulled that up. Never mind. But it's a Rockville granite and other related. It's coarse grained to pink to white. So I was like, all right, that fits my description. It's from the same area. That feels right, but it's it felt a little bit off, and I'm going to get more into that later. So, and I did some more research and I found it's probably related to the East Central Minnesota batholith. That's a fun word to say. And I think it is probably related to the Geon 17 post-tectonic granite intrusions. So you can see on the map right there, it says East Central Minnesota batholith, and that is the granite that I'm talking about right there, just to kind of get a sense. It's in this part of Minnesota. So my initial thoughts when looking at the granitic composition, we didn't really have class. It's kind of based on just what I read in the chapter in the book and what kind of my thought process was at first. The first one that the book went over was the alphabet system, but it's not exactly preferred for reasons I can't quite remember. I know there was some circumstances where there's type A, type S, and type I, and type S is supposed to be sedimentary, but there's some type S granites that don't form from sedimentary rock, so it's kind of iffy. I thought it might be a type A produced by partial melting or fractional crystallization. I thought it might be a Faroan granite from the 4 major granite types listed later in that chapter, again with extensive fractional crystallization of pyroxene, minor magnetite fractionization, or melting of crustal rocks. And I thought it might be metaluminous, so it just contained more calcium, sodium, and potassium than the feldspars could consume, just based on what I thought reading that chapter and everything. But I was very wrong, so buckle up, because this is where it gets interesting. I finally found one article that made it make sense, because my rock was from Rockville, Minnesota, and all the descriptions of Rockville granite seemed to fit the overall description, but none of it ever explained why there was that porphyry and that texture to it. And so it didn't feel quite right. And then I finally found one article that mentioned it, but it also had these really great diagrams that kind of showed me where I was wrong. So as you can see, the Rockville granite is the little diamond shape. It is actually paraluminous and an S type, so it's kind of why I mentioned it earlier. And it does fall in the Monzo granite section of this little ternary. The top part wasn't shown. And it is kind of on the line of theolitic and calc-alkaline, leaning more towards calc-alkaline, but I just thought it was more interesting, and it gave me a better idea of what the composition was and all of that. So basically, the granite that I have is kind of like a cousin of the Rockville granite in that they formed in the same area, but I learned that the reason why the feldspars were a little bit more rounded, it's a specific type of texture called the Rapakivi texture, which is more specific to that area, which is how I know it's related to the Rockville granite, because another type of granite found in the area, the St. Cloud red granite, does not have that. So it formed in Rockville in the same area, but it might have just, the way it uplifted was just slightly just different enough to form these phenocrysts, and only a very small amount of granite way. So that's why it was very hard for me to get information on the formation of this rock at first. And all I could find was things about Rockville granite, which fit most of it, but not quite. So as you can see, more on the side where the section was cut, you see the more rounded shapes. And then the thin section, I don't know if you remember it, there was the large rounded one on the side. So that's what the Rapakivi texture looks like. And I learned what that was by doing my research. So basically, granite forms through granitic plumes, and the Rapakivi texture is also indicative of a shallow formation. I think it was around 10 kilometers deep is where that usually occurs. And so high levels of SiO2, the sheet that had all the information had a source attached to it and had the composition and the weight. So I found it was about 70% weight SiO2, which means there was more water in the melt, making it buoyant enough to ascend through continental crust, most likely through pre-existing faults or shear zones and things like that. And with Bowen's reaction series, we've seen before in other presentations, progressive cooling leads to the formation of this felsic granite. You can see that there's the amphibole, the hornblende that we have, and then the biotite forms. And then before it can fully crystallize the potassium feldspar with the quartz, it got suddenly uplifted at some point that caused these phenocrysts to form. So it was slow cooling along a normal process, and then something caused it to just suddenly uplift, which gave the potassium feldspar phenocryst. I'm stuttering so bad. So what had happened was there was a Pinokian orogeny that occurred around, like, I think it would stretch from Michigan and Wisconsin into Minnesota, and that happened about 1.8 billion years ago. But the external and internal domains of the suture zone are like not present in Minnesota because of those Geon 17 granites intruding in and kind of like just covering it up. So there's no suture zone in Minnesota where that happened. So these Geon 17 granite intrusions came up, forming the granitic plutons. You can kind of see over here, we've seen similar diagrams like this before, where it started following the slow cooling process, which a non-porphyritic granite would follow, and then somewhere along the way, sudden uplift in a small area, causing only a small amount of the rockville granite to form in this way, caused the rapid uplift, causing the feldspar phenocrysts on the rock. But again, only a small amount formed in this way because out of all of the articles that I found, literally only one mentioned a porphyritic biotite granite forming that was very similar to the rockville granite and also found in Rockville. So not a lot, it's not very well documented. So too long, didn't read. Basically, mafic melt underwent partial melting to become more felsic or silica rich. The silica melt ascended upwards as a granitic plume around Geon 17. Granitic intrusions slowly rise and form the early ground mass minerals, the biotite, the hornblende, and some of the other feldspars that were in it. It was about 10 kilometers deep because of the Rapakivi texture that I see in the rocks, in the granite, in my granite, in the Rockville granite. Sudden uplift and cooling leads to the large feldspar phenocryst. The sheet, little arc sheet that came with it, said that it was gathered in 1935, and based on my research showing that there's a lot of mines and quarries in the area, it was probably mined, and that's how it was found. I don't know how, but it somehow ended up in the school's arc rock collection. So that's how we got it. Those are my sources. And then my other little boy, there he is. It's a pyroxenite with streaks of chromite. So you can see the overall rock here. And then in the little tray, there was also little kind of like bits that had fallen off. And I thought it was really cute and sparkly. So I took a picture of it. But basically, what I identified in it, there's chromite, hornblende, clinopyroxene, olivine, biotite, and nepheline, which I can't remember quite exactly where. It was somewhere up in this like top corner. But this rock was also really interesting to look at, especially as you can see with the upper polarin. So many crazy colors. The birefringence on this is super cool, but it's a fine-grained aphanitic rock. The streaks of chromite are visible in the rock, you can see here, and through the thin section. So I wanted to find a good part of that that showed both the chromite and all the other minerals in it. But yeah, that is all.
Great. Any questions? Any questions for Izzy? I've got a question, or maybe a comment. I really like the way, actually, Izzy, can you mute yourself for a second?
Yeah, sorry.
I don't know.
It's so
I'm getting a lot of feedback.
Yeah, it does that.
Okay, at least that sounds better to me. I really like the way you brought in a lot of outside research. It's like a detective trying to pursue, and that came through in your story. That was very nice. And discovering that Rapakivi bit is really neat. One, not that you need to do it at this point, but one interesting aspect to the Rapakivi texture is that the roundedness is sometimes because, and it sort of fits into your story, upward movement of the magma takes those feldspars into destabilized zone and they actually start to dissolve again and end up more rounded than they were. So you sort of hinted at that without explicitly stating it, but nice job.
Any other questions?
I have a sort
Okay.
of question. So towards the end, then, have you decided that your granite is paraluminous?
Yeah, because I know I talked to you a lot about it because you were originally going to do a granite. So it is a paraluminous leucogranite. It was closer to a leucogranite when I looked into that sort of thing, but I did decide that it was paraluminous because it was closer to the Rockville granite, which was paraluminous and like pretty far over. It wasn't really super close to that line that it was metaluminous. So that's how I came to that decision.
Okay, I'm proud of you.
Izzy, can you define that term since you've used it, paraluminous?
Oh my goodness. It's it has more like it's potassium and sodium and calcium than the feldspars can consume. Correct?
So it has more aluminum. I think you said it has more aluminum than those alkaloids. Yes, good.
Okay. Thank you. Stop presenting them if I don't have any more questions.